Hello and welcome back. We're going to do two-car problems again, but this time cars are going in the opposite directions, either towards each other or away from each other. A little bit different than the other car problems we've done. And these, you have one picture with both cars on the same line, and the same equations apply though. And the first one, two cars start from the same point and move in opposite directions. Both cars travel at 60 miles per hour. How far apart are they after 2 hours? This is the distance they will be far apart, D. And this is D1 and D2. And what are we given? V1, D1, T1. V1 equals 60 miles per hour. Don't know D1. And time is 2 hours. For V2, we have V2 equals 60 miles an hour. Don't know D2, and T2 is 2 hours also. Same equation applies. D equals VT, and we know that D, the distance they're apart, equals D1 plus D2. And replacing these D1s with a V and a T, V1 T1, D2 is equal to V2 T2. And we have all the information. V1 T1 V2 T2 equals 60 times 2 plus 60 times 2. So D equals 120 plus 120. And the distance they are apart is 240 miles after 2 hours. In this problem, two cars are starting from the same point, going in opposite directions at the same speed, 60 miles per hour. How much time does it take for them to be 70 miles apart? Here is the distance they are apart. Let's call that D. Let's call this car 1, car 2. This will be D1 and D2. And what do we know? V1, D1, T1. V is 60 miles per hour. D1 we don't know. And we got to find T1. What do we know about the second car? V2 equals 60 miles per hour. Don't know D2 or T2. But we know D. D equals D1 plus D2. And D is 70. V1 T1, V2 T2. And we know that T1 equals T2, so we can replace it with just a generic T with no subscript. So 70 V1T plus V2T. We can factor out the T of V1 plus V2 and take the term with the variable, I put it on the left side, and 70 divided by V1 plus V2. So T will equal 70 over 60 plus 60. And the time it takes for them to be 70 miles apart will be 70 over 120. Simplify that a little bit, you get 7/12 of an hour. That's how long it'll take them to be 70 miles apart. We can check that. Got 7/12 applies to both cars. So let's just take the first one. Distance d1 equal v1 t1 equals 60 times 7/12. That'll be 35 miles. And d2 would be the same since the value of the velocity and the time are the same. So d1 plus d2 is 70 miles. Here two cars start from the same point. Car 1 going 70 miles an hour and car 2 going 50 miles an hour. How far apart are they after 1 hour? So this be car 1 and this be car 2. And the distance they are apart is d. This would be d1 and this is d2. And what do we know about these cars? We've got v1 going 70 miles an hour. We don't know the distance, but we know the time equals 1 hour. And what do we know about the second car? V2, D2, T2. V2 is going 50 miles an hour. We don't know the distance. We know the time is 1 hour. We know that D will equal D1 plus D2. And substituting V1 T1 plus V2 T2. T1 and T2 are the same, so just call it a generic T. You got V1 plus V2. And we can stick in the numbers. D equals 1 hour plus 70 plus 50. So D equals 120 miles. After 1 hour, they are 120 miles apart. Here we have two cars starting from the same point at the same time, traveling in opposite directions. Car 1 travels at 15 miles an hour and car 2 travels at 30 miles an hour. How far apart are they when car 1 has gone 20 miles? Again, here's the distance D, which we've got to find out. This would be car 1, so it's car 2, at D1 and D2. What do we know about the cars? V1, D1, and T1. V1 equals 15 miles per hour. D1, we don't know. T1, we don't know. And car 2, got V2, D2, and T2. And we got V2 equals 30 miles an hour. With my car 1, it's gone 20 miles. So D1 equals 20 miles. And from that, we can figure out the time it takes car 1 to go 20 miles. That D equals V1 T1. So T1 equals D1 over V1. T1 equals 20 over 15. Simplify that, we'll get 4/3 hour. And to find D2, we know T2 has to be 4/3 hours also, so we get D2 equals V2 T2, D2 equals 30 times 4/3 of an hour. That means 40 miles. So we find D, the distance they are apart. D1 equals D1 plus D2. D1 was given as 20 miles. And we calculated D2 as 40 miles. So the distance they are apart after car 1 goes 20 miles is 60 miles altogether. They're 60 miles apart. And this problem says two cars start at the same point, going in opposite directions. Both are going 50 miles per hour. Car 2 leaves 1/2 hour later than car 1. How far apart are they when car 1 has gone 3 hours? How far apart are they? That'll be D. Make this car 1, car 2, and D1 and D2. What do we know about the cars? V1, D1, T1. V1 equals both are going 50 miles an hour. To find D1 and figure out the time in a second here. V2, D2, and T2. V2 equals 50 miles per hour. D2 we have to find, and T2. Car 2 leaves 1/2 hour later than car 1. And this is always tricky to figure out the time and the relationship between the two cars concerning time when one leaves later or if one stops while the other one's going. The easiest way I found was, here's the start, and they're both not in motion. Now it says car 2 leaves 1/2 hour later than car 1. At first they're both standing still doing nothing, and car 1 takes off first for 1/2 hour. And say that's the 1/2 hour mark. Write down 1/2 hour as time so far for car 1. And at that point car 2 takes off, so they're both in motion. And the remaining time for car 1 will be the same time that it takes car 2 to finish, up to 3 hours. So car 2 and car 1 are in motion at the same time, but car 1 is over here, and the rest of the time for car 1 is equal to the time for car 2. So you can write that down as total time for car 1 is 1/2 hour, it goes by itself, plus T2, the time that both cars are in motion. So we have T1 equals 1/2 plus T2, and we're given we want to find the distance apart that the cars are when car 1 has gone 3 hours. We want to work out when T equals 3, when T1 equals 3 hours. And then you can solve this equation here. 3 equals 1/2 plus T2. So T2 will equal 3 minus 1/2, and T2 will equal 2.5 hours. And then again, starting from D equals D1 plus D2, you got V1 T1 plus V2 T2, and we know all these values here and just plug them in. Have 50 miles an hour for car 1, and the time for car 1 is 3 hours, plus 50 miles per hour for car 2, and car 2 is 2.5 hours, 5 halves. So this is 150 plus 250 divided by 225. Total distance apart is 275 miles. That is how far apart they are after when car 1 has gone 3 hours. In this problem, 2 cars start from the same point, going in opposite directions, both going 50 miles per hour. Car 2 leaves 1 hour later than car 1. How far apart are they when car 1 has gone 80 miles? Let's have this car 1, and this will be car 2. This will be D1 and D2. And what do we know about the cars? V1, D1, and T1. V1 is 50 miles per hour. D2 we don't know, and T1 we don't know. Find the relationship between T1 and T2 in a moment. V2, D2, and T2. Second car, 50 miles per hour. D2 we don't know, and T1 we have to figure out. Again, both cars are sitting motionless, and car 1 starts and goes 1 hour. And at that point, you can write 1 hour for T1. And at that point, car 2 starts. So both cars are in motion, and the rest of the time for car 1 is equal to the same time that car 2 goes. So it would be 1 plus T2. Again, both cars are sitting still. Car 1 moves, C1 stays. Car 1 goes an hour. Write down an hour, and the rest of the time, and then car 2 is in motion, and the rest of the time they're both on the road for the same amount of time. And you can call that time T2. So we know that T1 equals 1 plus T2, and T2 equals T1 minus 1. And we have D1 equals V1 T1. We want to find the time it takes for car 1 to go 80 miles. So we have the distance 80 miles, and we have the velocity 50, and T1. Moving this over there on the left side like I always do, and you'll have 80 divided by 50. So T1 equals 8/5 hours. And from T1 you can calculate T2. T2 equals T1 minus 1 hour. T2 equals 8/5 minus 1, 5/5. And T2 equals 3/5 of an hour. And from these you can calculate the distance apart. D1 plus D2. D1 we're given, it's at 80 miles. So we know D1 equals 80 plus V2 T2. We have D equals 80 plus 50 miles an hour times 3/5. So D equals 80 plus 30. Distance apart after D has gone 80 miles is 110. 110 miles apart. In this problem, 2 cars are 300 miles apart, heading for each other. Both cars are going 50 miles an hour. Find the time it takes for them to meet. Here they are. We know D given is 300 miles. This will be car 1, car 2, D1, and D2. What do we know about the cars? V1, D1, T1. Going 50 miles an hour. D1 we don't know. And the time is what we want to find out. And for the second car, we have 50 miles an hour. D2 we don't know, and time we don't know. But we do know that T1 equals T2. They're both on the road the same amount of time. And as always, we have D equals D1 plus D2. D we're given 300. D1, V1, T1 plus V2, T2. And since T1 equals T2, you can just use a generic T without the subscripts because it's the same numerical value. So you'll have 300 equals V1T plus V2T. And factor out a T from this side, you'll have T times V1 plus V2. And moving the T over here and dividing both sides by V1 plus V2, you'll have 300 divided by V1 plus V2. And plug in the values, the time, it'll be 300 divided by 100. Time is 3 hours. In 3 hours, they'll meet. Thanks for watching. I'll see you again.